Okay, so we talked about elimination method, okay, or the addition method. Why was it called the addition method? Anybody remember? Awesome. Because we end up adding, okay? What are we looking for? What's our goal? When we're looking for our coefficients. So like looking at example A or example B, we were looking for coefficients that were the same but had, how were they different? Different signs. Good. Okay. So that was elimination or addition method. Okay. The other two methods we've talked about already is graphing, which is fine, but not as exact. Okay. And then our first one was substitution. When was it good to use substitution? When was it good to use substitution? What were we looking for? Okay, so when either X or Y are already solved for, okay, that's what we're looking at. Okay, so looking at example A, and I don't have my Apple Pencil, give me a second. Looking at example A, which method do you think we should use? Do we want to use substitution, elimination, or graphing?
Either one works.
Either one works. Right. Okay, so I agree. Any one of them will work, but which one's going to be the easiest to use? Okay, so if we use substitution, let's talk about that. Okay, if we were to solve for a variable, more than likely, we're going to get what when we solve? A what?
Fraction.
A fraction. Do we like working with fractions?
No.
Okay, no, we can, but we don't prefer it. Okay, so instead, let's use elimination. If you use substitution on your paper, see if you get the same answer. That's fine. Okay, so elimination. Do we want to get rid of X or Y? Phones away, guys. Okay, get rid of Y. So we're looking at 12Y and negative 2Y. So what's the smallest number that they both multiply to be? Can we multiply 12 by something to get to negative 2?
Multiply negative 2 by 6.
Okay, Allison said we can multiply negative 2 by 6. And if we do that, distribute it to the whole equation, what's 3x times 6? 18x. What's negative 2y times 6? Negative 12y. And what's 27 times 6? Is it going to be positive or negative? Negative 162. So if we bring over our top equation, we look at our y values. Do they have the same coefficient? Do they have opposite signs? So when we add them together, what's 6x plus 18x?
24.
Good job. 12y plus negative 12y. 0, it cancels. And what's negative 6 plus negative 162? Negative 168. Oops. Okay, how do we get x by itself? Divide by 24. So x equals, what's 168 divided by 24? All right, so negative 7. But what were our solutions always? What should our solutions always be with systems? An ordered pair. So we found x. How do we find y? Okay, plug negative 7 back in. Which equation do we have to plug it back into? It doesn't matter. Okay, which one do you want to plug it back into? Okay, so if we plug it into the first one, 6 times negative 7 plus 12 times y equals negative 6 What's 6 times negative 7? Negative 42 plus 12y equals negative 6. Then what do we do to solve for y? Add 42 to both sides. So 12y equals, what's negative 6 plus 42? 36, good. And to get y by itself, divide by 12. What does y equal? And what is our solution? The ordered pair, negative 7, 3. Okay. Questions with that?
The opposite way, but still got the same answer.
Okay, what way did you do it? Did you use substitution?
I did elimination and substitution.
Okay, so when you did elimination, did you do the x's instead of the y's? Maybe. Okay, so let's talk about that, because that's exactly what I was going to ask next. Okay, so what if instead we wanted to get rid of our x's? Let's talk about what would we multiply by. So we have 6x and 3x. What could we multiply by so we get the same number but opposite signs? 2 on which equation? The second one. Okay, so if we multiply the bottom equation by 2, we would get positive 6x. So what do we actually want to multiply by instead? Negative 2. Okay. If you're having problems with that part, that's probably the hardest part, is figuring out what do I multiply by? Okay, just switch the numbers. Okay, so what we can do instead, okay, I thought I erased that. There we go. Just swap them completely. So we're going to multiply this equation by 3 and this one by negative 6. You're going to get larger numbers, but it will always work that way. Okay. So if you're having issues figuring out what to multiply by, swap the numbers and make sure one of them gives you a positive and one gives you a negative. Okay. All right, let's look at B. 3x minus 2y equals 38, and x minus 6 equals y. Should we use elimination, substitution, or graphing? Why should we use substitution? We already know what y equals. Y is already by itself. So I can take this x minus 6, and where am I going to plug it in? After the, we're going to plug it in for the y. Okay. All right, so if we plug that in, we have 3x minus 2 times the quantity x minus 6 equals 38. Now we have an equation with just x in it. So how do we solve? Distribute. So 3x, what's negative 2 times x? Negative 2x, good job. And what's negative 2 times negative 6? Positive 12 equals 38. 3x minus 2x is 1x. Plus 12 equals 38. How do we bring down the 12? Subtract it. So x equals, what's 38 minus 12? 26. Are we done? Bring it up to solve for the y value. Which equation do we want to plug it into? Does it matter? No, which one's easier to plug into? The second one. Cassidy's doing it too. So if we do 26 minus x, or sorry, minus 6 equals y, what does y equal? 20. Thank you, Ella. And what is our solution as an ordered pair?
26, 20.
26, 20. So that one would have been really hard to graph. Yeah. Okay, and that was it, right? We only had those two examples to go over.
Yeah.
All right. Okay, so today, your homework. Am I good to stop sharing? Do we get that all written down? Okay.